Okay, welcome everybody. This is the week 2 webinar for the online stats class. And so it's hopefully you've gotten used to it a little bit. And I want to talk about all the things that we're going to do today because there's it's kind of a good list. So the first thing that we always do is I'll answer any questions you might have. You can post them in the chat box and that'll be private. And you can call it out too if you want, but then they'll hear your voice. And but I'll happy to answer any questions you might have, and not just the beginning, but throughout the whole webinar. And then today is all about chapter 3, at least for the new statistics material we're going to do today. It's all about chapter 3. And chapter 3 is on probability. So probability is an important part of statistics. We'll define probability, and then we'll look at different probabilities. We'll also do things like, you think I'm going to win? It's the lottery. And what's the probability of me winning the lottery? And that's kind of something interesting. I use that sometimes. So then we'll talk about, I know this looks really weird, and I know you guys know what and means, but what does it mean in terms of probability? Similarly, we'll talk about what the word or means and what the word given means. So there's all kinds of different words in probability that have mathematical meanings. And we'll talk about mutually exclusive events. And we'll talk about independent events. And that'll be chapter 3. I want to give you kind of a heads up. I like to think of probability a lot like kickboxing. Not sure if any of you have done kickboxing, but I think you probably will agree it's a whole lot easier to watch two people kickbox than to be in the rink and actually kickbox. It's much more painful to kickbox. And trust me, from my personal background, I teach statistics, you know that. I teach math. Any guess on what else I've taught besides math and stats? So you'll think about it. Yeah, kickboxing, a little bit of that, but more specific, karate, martial arts. So I taught martial arts, and it is a lot harder to actually be in the ring than to, than to watch someone else do it. Trust me on that one. Similarly, watching me do probability is not going to be that hard at all. But doing it yourself is tough. So make sure you get help. Make sure you do lots of practice, and that will help you out a lot. We're going to finish off talking about Project One. Project One is, a pretty significant part of the grade for the class and an important part for learning. So Project One and Two, actually. And in terms of when I talk to students like 5 years after they took my class, and I asked them, what was the most important part and what helped you the most for learning in, what you used. And pretty much all of them tell me the projects, because that actually brings it to reality, gets you to do what you're interested in, and you really, use statistics instead of just answer some random questions that come from a computer. So Project One is really important, and I'll talk about it pretty much today. So you'll be ready to start doing it. So that is the plan for today. I want to let you know that this is week 2, and 2 is an even number. Why is that important for this class? Why is it important that we're in week 2 and 2 is an even number? Any thoughts? Don't see y'all jumping in. All right, so if you're not sure, I'll tell you. Every even number week, you have your exam to do. So this week, by the end of the week, you need to have taken exam 2. And the exams are worth a lot more than, the regular assignments and stuff like that. So make sure that you get ready for the exam. I want to mention the exam, it's a 90-minute exam. After 90 minutes, it's over. So if you can't do the last 5 problems because you don't have time, then you didn't have time and you get zeros on that. So the way the exams are for this exam, it'll look at chapters 1, 2, and 3. It actually takes the homework problems. And I don't know if you realize, but the homework problems that you're assigned are randomly generated. And so basically, you won't see necessarily the exact same questions that you got on your regular chapter assignments, but they're randomly generated from the same question pool as the questions that you had on your regular assignments, except for the last maybe couple problems. And those are questions that are also randomly generated, but you haven't seen them because on those, you actually have to type out your full answer instead of just a number, but you need to write like sentences. And then I personally read through the sentences and give you a grade. So when you submit your assignment, it'll show a 0, but usually within, a few days after the due date, I'll have it graded and then you'll see your score. So just a little note on that. I don't remember. There's usually like 18 or 19 questions, something like that. So just be ready. Just be ready. So I don't remember the exact number of questions, but something like that. Okay, are there any other questions? Any other questions? Okay, if not, then hopefully you've heard the word probability. That shouldn't be a new word to you. I'm sure that's a word you've heard a lot about. And it's a big part of this class. And in particular, it's really what this week is all about. So we want to start out by saying, what does it mean to even say probability? Sometimes it's good to kind of look at examples and hopefully you know what is, besides skiing and snowboarding, do you know what else Lake Tahoe is kind of like known for? Skiing, snowboarding in our lake. You know what else it's known for? A lot of people come here for it. Yeah, gambling. Okay, gambling is another one. So I figured, even though you're probably not gamblers, um, yeah, hiking too, but gambling is the one we're looking at. And in fact, by the way, I used to gamble, but don't anymore. Because there was a time when they told me they'd kill me if I ever came back, and I'm not doing that again. I don't want to die. So that's a whole different long story. But if I pick a card, figured, since we're here and this is a casino card, then I could say, what is the probability that this card is a king? And what does it even mean to say what is the probability that? So you've probably thought about things like that. But if I pick a card or if the other thing that we have in the casinos are these guys, these are dice. And if I roll a die, what's the probability that the die roll is a 5? Or, have one of these guys. If I take a coin and I flip the coin, what's the probability that it lands heads? Okay, so I think that hopefully you know that if you flip a coin, no cheating allowed, just a random flip, that the probability of heads is a half. Do you all know that? Is that something that you've all kind of getting used to? Okay, now let's see why is it a half? And the key is, one thing is probabilities are fractions. Whether you like them or not, that's what they are. So there's a 1 on the top and there's a 2 on the bottom. And what this comes from is the 1 on the top is that if you look at the head, the coin, one of the sides is a head. Does that make sense? So the 1 on the top is because one of the choices that could happen is a head. And the bottom is a 2 because there are 2 sides of a coin. Does that make sense? All right, if I want the probability that I pick a card and it's a spade, then I do the same idea. I say, well, how many cards are there in a deck? Do you know how many cards there are in a deck? There's 52 cards in a deck. So the denominator of the fraction will be 52. Do you see how that works? How many spades are there in a deck? So if we look at that, for example, as a spade. Do you know how many spades there are in a deck? Okay, there's the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. And if you count those, there are 13 spades in a deck. So the numerator for the probability of picking a spade is 13. The denominator is 52. So the probability of picking a spade, if you randomly pick a card, will be 13 over 52. Any questions on this example, these gambling examples? Okay, so probability, the idea of it is actually quite simple. It's just the number of things that can happen divided the number of things that make you win or make it happen divided by the total of things that can happen, given the fact that everything has an equal chance. So every card, I'm not cheating. Every card has an equal chance of getting picked. Similarly, I'm not cheating. Every side of the coin has an equal chance of being landed on. Okay, any questions on the idea of what probability is? Any questions on that? Okay, so here is the formal definition, and that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur, given that all things that can occur have equal chance of happening. So we say mathematicians are pretty boring. We're going to letter used for P for probability. It's a good letter for probability, isn't it? Since it's the first letter of probability. So we always write capital P, and then we write parentheses, and then whatever you're looking for the probability of, in this case, it's A, and then end the parenthesis, and then equal sign, and then it's going to be a fraction. In the numerator will be the number in A, and the denominator will be the number in the entire set. Any questions at all on the simple definition of probability? Okay. Are all probabilities easy to calculate? What do you think? Sounds easy. Yeah, the answer is absolutely not. There are brutal probabilities. We're going to be doing some that are harder than this one. Sounds easy, but no, they can get really hard. We're going to do the ones that you might feel they're really hard, but nothing like the really, really hard ones. So how about this one? What I'm going to do is I'm going to mix the deck. Sound good? And then I'm going to pick a card, and I'm going to pick another card. So I pick 2 cards out of the deck randomly. That's important, that it's random. And what is the probability that both of these cards are kings? That's not as easy, is it? Because saying, well, even how many ways are there of picking 2 cards out of an entire deck, that's a little bit tough too. But also, what's the probability of picking 2 kings? Well, how many ways are there of picking 2 kings? That could take some work too. So does everyone understand what the question is? What's the probability of both of these cards being king? Okay, so one guess would be 2 out of 52, but that's actually not correct. Okay, it turns out there are many, many different pairs of 2 cards, not just 52. Because you can have an ace of spades, a king of hearts, an ace of diamonds, a queen of clubs. I can go on and on and on. Okay, we're talking thousands of different choices. Does that make sense? For two different cards. So we're not going to even be able to count, or we're not going to count how many there are of possibilities. We're going to do it a different way. So don't just say 2 out of 52 because that doesn't work. So instead, here's what we're going to do. We're going to look at these one at a time. We're going to start with this first king. Okay. So let's see, what is the probability that the very first card is a king? That actually should be pretty easy. So I picked two cards. What's the probability the first one is a king? Well, that one we can do pretty quickly. I can go and I'm going to insert an equation. So I can make it a fraction. How many kings are there in this deck? And it says a real deck. Yeah, there's 4 kings, so it'll be 4. How many cards are to pick from this deck? Yeah, 52. So the probability that the first card is a king is 4 out of 52. All right, the problem is if I pick the first card and it's a king, then the probability the second card is a king is no longer 4 out of 52 because this card is in my hand and it's the other card that I'm interested in. Do you see that? So I have information about this first card. That changes the probability for the second card. Okay, so both kings we're not ready for yet. But what we can say is find the probability the second card is a king if we know the first card is a king. So now what we do is we put an equation in. It's going to be a fraction. And we think about it for a minute. This first card is a king of spades. You see that? How many kings are there for this to be? The second card. There's only 3 left because I've already picked the king of spades out. Do you see that? So that means the numerator is a 3. The denominator is no longer 52. How many cards could the second card be? 51, because it's not the king of spades. Do you see that? So the probability that the second is a king, given the first is a king, will be 3 out of 51. Any questions on that so far? All right. So I want to let you know some notation that's important. Again, it's written here, but I haven't kind of talked about it, so it's really important. So when you want to say, well, what's the probability the second is a king? If you know the first is a king, then this is the notation you use. P, we have, all right, K2 for the second is a king. And then this little vertical line segment right here, little vertical dash, means given that, or we know that. So given that, and then after to the right of that is what you're given. We're given the first is a king. Find the probability the second is a king. Any questions on this notation? Does that make sense? Okay, so very important notation. Okay, then we can use what's called the multiplication principle. And that says the probability of A and B. So the probability of the two things both happening is equal to the probability the first happens, the probability of A, times the probability that the second happens given the first happened. Any questions on this big formula? Just note, in this class, do you need to memorize formulas? Do you need to memorize formulas for this class? What do you think? Okay. It could be helpful. It turns out you don't have to memorize them, but here's what you do have to know how to do. You have to know when to use them, because again, there's be some like word problem, and you have to know there's a formula I need to use. What was that formula I have to use? So you have to know how to find it. And then, of course, you have to know like where it is on your notes that you're taking. Hopefully, you take some notes on these lectures. Okay. So you have to like know where to find it and know when to find it. Because if you don't know when to find it, then that doesn't mean anything because there's a formula you never look at. And if you don't know where to find it, you won't be able to find it. And again, that place could be in your brain, but it could be on paper, but you have to know how to, you have to be able to quickly get it. Because remember, the exams are timed. You have 90 minutes. So if it takes you too long to go find a formula, then you'll run out of time. Any questions on that? Okay, so this is an important formula. Make sure you either know it in your head or have it written down and definitely know when to use it and where to find it. Okay, so now we're able to answer the question. So the probability of finding two kings, of getting two kings, is the probability that the first is a king times the probability the second is a king given the first is a king, because that's what the A and B are. And if you get two kings, it means the first was a king and the second was a king. Do you see how that's an and? So note that the question will not always have some of the key words like the word and. You have to be able to read it and see that this is an and question. What is the probability that both will be kings? Another way of saying it is what is the probability the first is a king and the second is a king? So you have to be able to, read a question and be able to turn it into something like that. So then we just multiply. Probability the first is a king was 4 out of 52. The probability the second was a king was 3 out of 51. And what we need to do is you're always in this class, always allowed to use a calculator. So you put this in a calculator. You do not want to, I mean, maybe you do. Maybe that's like how you have fun. Do it by hand. But putting in a calculator is quite easy. The calculator I tend to use for just arithmetic is Google. So if I just type in 4 divided by 52, and then times is a star, 3 divided by 51, it just gives it to me. I don't have to even hit enter, it just gives it. You have to know that the star is the times, but that's it. So you don't have to use Google, but it's an easy one to use for basic arithmetic. And for a lot of other things. Okay. So it's about 0.00452, etc. Okay. If it said round to 3 decimal places, what would you type if it was a computer question, like the exam might make you do some rounding? How would you round that to 3 decimal places? Yeah, not 0.004, 0.005. Good, good. Some of you got it, some didn't. Don't forget, you go to that third decimal place is a 4, but the fourth is 5 or bigger. So that means that 4 becomes a 5. You change it. So that to 3 decimal places would be 0.005. And I want to give you a heads up when you're doing homework that is graded by the computer is not nice to you. Okay. So make sure you get rounding done correctly and read the instructions. If it says round to 4 decimal places, then you need to go 4 decimal places. So do what it tells you. So make sure you pay attention because that little tiny mistake means and if you make it's an exam, you just lost it. Does that make sense? So if it's a chapter assignment, it means you have to start over again and redo the whole problem with different numbers and different, type of problem. So real important to pay attention to that. Okay, so the next question, another card. Cards tend to be really hard. So I give these to you because you're not just going to guess the answer. That's too hard. So we got a deck of cards. No cheating allowed. So here's the deck. Okay. And suppose you pick 5 cards at random from the deck. Okay. I don't know if have any of you ever played poker or at least know the rules of poker? I actually used to teach a class called the Mathematics of Poker. That was a long time ago, but still good. Good. Looks like at least you know the rules of poker. So let's suppose you pick a 5-card hand. Poker has 5 cards. Okay, there's more complications, but I'm not going to do the complicated stuff. What's the probability of just those 5 cards being a royal flush? Okay, do you think it's likely or unlikely to get a royal flush out of 5 cards? What do you think? It's kind of likely, it's really hard and rare, or it's really happens all the time? Okay, so those of you who played are saying unlikely or very rare. All right, so we know this number is going to be pretty small, but we got to do it. So what we're going to do is say probability of a royal flush are going to be the number of royal flushes divided by the number of poker hands. It's a 5-card poker hand. So let's start out with the easy one. So by the way, if you don't know poker, a royal flush means that you get ace, king, queen, jack, 10, all of the same suit. Okay, so, and order doesn't matter when you look at hands. So ace, king, queen, jack, 10, we're just going to call that the same as king, ace, queen, jack, 10. That'll just be one thing. So how many royal flushes are there? And that's easy. That's a hint. How many royal flushes? Yeah, there's 4. You can have a royal flush of spades, diamonds, clubs, and hearts. Okay, one of those 4 will make a royal flush. So that's going to be a 4. Any questions so far? Okay, number of poker hands. That I don't think any of you are just going to be able to do that in your head. Okay, there are so many different 5-card poker hands. But what you can do is you can say what we're doing is we're starting with a 52-card deck and we're picking 5 cards. And there's some tough math involved in coming up with the how many. So you have a choice. You could do the really tough math, or you can trust the calculator that does it for you. What would you rather do? Okay, yeah, my guess is you're going to want to do the calculator. Any of you want to do the tough math, you need to come to my office hours. I'm not going to talk about it during the webinar, but I do want to show you how to use calculator. So remember this calculator? This is the calculator I created that works. Okay, so this calculator, we're going to do combinations and permutations. Remember, I created this calculator in order of the things we do. And last week we did z-score. Remember that? This week we didn't do combinations and permutations, so that's this week. Do you see? By the way, next week we'll do expected value and standard deviation. But this week we're going to do combinations and permutations. And n are the number that you can start with. How many are in here in this whole deck? That's n. What should I put in? 52. Because there's 52 cards to choose from. How many cards am I choosing? 5. So that's R. Any questions on that? All right, so the next thing I'm going to tell you is these 2 different things. This guy, C for combinations, P for permutations. Combinations is when it doesn't matter what order these are in. Permutations is it does matter. When you get 5 cards in, out of poker, do you care what order the cards came in if you just pick them up and look? What do you think? Does it matter whether it's ace, king, queen, jack, 10 or 10, jack, queen, king, ace? In terms of looking at the 5 cards and deciding if you're happy about it? Okay, it turns out no, it doesn't make any difference. Okay, if you have a 10, jack, queen, king, ace, you still got the royal flush. If you have an ace, king, queen, jack, 10, you still have the royal flush. So when you're talking about poker, order doesn't matter at all. So when order doesn't matter, I'm going to click the CNR. Okay, it's not a small number. It's 2,598,960. Okay, that's a big number. So a little more than 2.5 million different ways. There's no way you can be able to list all of the different possibilities that could happen. So I can copy and paste that in. Any questions on that? All right. Sometimes you'll be asked to write as a fraction, sometimes as a decimal. I don't think you'll ever be asked to, probably not to reduce it. Nothing like, never when it's big like this. So if we want it as a decimal, Google works fine. You just take 4 and then divide it by, and that big ugly number. And take a look what we have here. And this is really important. Let's see. Actually, I liked it better. Is it 1.539 about? Is that the answer? Okay. So the answer is absolutely not. So this is very important. You can never have a probability greater than 1. You can't have more than 100% chance of winning. Do you agree? Doesn't even make sense. What that means is I'm not looking at it right. If I think it's just about 1.539 to 3 decimal places, what did I miss? Anyone know? This is very common with calculators. Any of you see what I missed? All right, you're not guessing. To the very far right, see this E -6? That is really important. Do you know what the E -6 means? You're going to see this a lot in this class. An E with some number, some negative number usually. Anyone know what that means? Okay, it's the way computers do things, and we use computers. So what that means is move the decimal place 6 digits to the left. So instead of 1.539, I'm going to think 1.539, but I need to take that decimal place and I need to move it 6 places to the left. The first time is just to the other side of the 1. The others, you have to put zeros every time. So it's going to be the first one's free, and the next 5, you have to put zeros. So it's going to be point, and then 1, 2, 3, 4, 5 zeros, and then 1.539. And it's a tiny number. Okay. So it's less than, so it's like a little more than 1 in a million chance to get that. Like 1.5 in a million chance to get a royal flush out of 5 cards. Any questions on any of the stuff that we've done so far? All right. All right, let's look at the next question. All right, let's suppose you're gonna take the exam, okay? And let's suppose that this exam was all multiple choice, okay? It won't be, by the way, but let's suppose you had an exam that was all multiple choice. There were 20 questions on it, and each of the multiple choice questions have 4 different choices. Then what's the probability of getting them all correct? Any questions on the question? By the way, do you think it's going to be very likely, kind of likely, or not very likely at all? Just as a feel. It's always good to get an idea for that so that when you actually calculate it, see if it matches what you think is right. If you randomly guessed on 20 different questions, probability of getting them all right, do you think that was going to be very likely, not too likely, or very unlikely? Any thoughts? Let's see you jumping in. Yeah, not likely, very unlikely. Okay, so here's what this is different because here's the thing. If I guessed, say, C for the first question, then I'm allowed to guess C for the second also. So unlike the cards, where if I got a king for the first card, then that specific card can't be picked again. That's not happening when we have this multiple choice example, is that if you pick something, you can pick the same answer for the next question. Nothing changes. So because of that, it's actually easier. You don't have to do any of this, how many are left kind of stuff. You just look at it one at a time. What's the probability of the first question being correct? What's the probability of getting the first one right? Let's see if you can tell me. That's not supposed to be a hard question. It's a multiple choice question. There's 4 choices. What's the probability of getting lucky on that first question? Yeah, 1/4. Just because it's easier to type, I'm going to write 0.25. That's for the first one. And now I'm going to multiply, but I'm going to do this given stuff. What's the probability of getting the second one right? If I know I got the first one right, which means nothing. What's the probability of getting the second right? Yeah, still 1/4 or 0.25. And the third one, same thing. And the fourth one, same thing. So they're all going to be 0.25. If I multiply 0.25 by itself 20 times, how can I rewrite that as an expression in math? Not too hard. You remember? It's 0.25 and it's to the 20th power. Any questions on that? Okay, and I can pop that in Google. 0.25 to the 20th. And by the way, it's not 9.09 or so because of that E negative 13. It's going to be very, very close to zero. There are going to be 12 zeros before that 909. And I figured I should let you know these calculators that I created also have a scientific calculator button, and that means you can do that stuff too. So you just do 0.25 and then power button. Whoops, wrong power button. That was my mistake. And then power button to the 20th. And it gives you the same thing, 9.09 times 10 to the negative 13th. That shows it that way. But the way you're going to be, typing it in, if you're going to be typing in with decimals, is 12 zeros before the 9. Any questions on that? Okay, we call that type, by the way, with replacement. With replacement means that if you got something on the first one, you're allowed to get the same thing on the second one. Whereas without replacement, you're not allowed to get the same thing on the second one. Any questions on that? Okay, so just a note, and this is really important, if it's with replacement, the probability of A and B equals the probability of A times the probability of B. And if that equation is true, then we call the variables, or we call A and B independent. Can you remember that word? That word's important today. So important, I'm going to highlight it with red. So we call it independent. I'm going to say it loud too. Any questions on what it means to be independent? By the way, if it's not independent, what word do you think you'd use? Hopefully you know this is English more than math. If the probability of A and B is not equal to probability of A times probability of B, what do we call it? It's an English question. So what does it mean to not be independent? Yeah, dependent. Okay. So if you don't have an equal sign, we say it's dependent. All right, ready for the lottery? All right, so just a note, here's the lottery. By the way, which of these three do you think you should buy a ticket from if you had to buy a ticket? Which ticket should you buy? Should be obvious. Yeah, Powerball, $208 million. Good-ding. That's Powerball. So let's understand how to, what it means to play Powerball. Have any of you played the lottery before? Okay. Yeah, you played the lottery? Okay, so here's how to play. You might know anyway, but you may not. For Powerball, here it is. Okay, pick 5 numbers between 1 and 69 and 1 number between 1 and 26. Okay, and the numbers between 1 and 69 have to be different numbers. Okay, the number between 1 and 26 can be any number. It could even be one of the ones you pick between 1 and 69. That's allowed, just to note. Okay, and that's important to think about. Okay, then what happens is out in Sacramento, they randomly pick numbers. And if their numbers match your numbers, you win. And if their numbers don't match your numbers, you don't win. And I'm gonna be greedy, and I'm gonna only want to win this $208 million. I don't want to win the second prize. I want to be 100 millionaire here. Sound good? And it makes the probability a lot easier for us. All right, so you may not be able to see it, but I bought this is 2 tickets. So let's find out the probability of me winning the lottery. So what we're going to do, and you should be used to this, I'm going to create a fraction. What's the numerator of the fraction? What's the numerator? Should be really easy. No, it's not. I'm not sure we got 6. It's not 6. No, it's not 5. Here's a hint. How many numbers did I pick? How many, I picked, I got 2 tickets. So it's 2 because there's two different things that can make me win. Do you see? Any questions on the numerator? That was easy if you listened to I got 2 tickets. The denominator is a little harder. I need to get 5 correct out of this 169. So what do I need to do? Let's see, y'all jumping in. I need to go to the calculator. And it's the same calculator. But n's not 52 anymore. N was 69. Okay, so now that means in the calculator, n is 69. And I need to get 5 correct. So that's R is 5 in that case. Okay, the order doesn't matter with the lottery. So I calculate it. Good chance? Not at all, but it is what it is. That's how many there are for the 5 correct, but I'm not quite done yet. At least I can put that part in. But I also have to get what they call the power number between 1 and 26. And those are independent of each other because they can repeat each other. So I just multiply. There's 26 ways of picking a number between 1 and 26. Any questions on that? So then I'll drop it in the calculator. Now I got a new stuff to put in. So we're going to have 4. We're going to have a 2, and then divided by this guy. And it's 6.8445953 times 10 to the negative 9th power. So that means there's 8 zeros in front of the 6845. Six, 4, 4, 5. Is that right? 6, 4, 4, 6, because I should round if I'm going to do it to that many decimal places. Okay, and by the way, just the way I like to read this, 10, 100,000, 10,000, 100,000, million, 10 million, 100 million. So I have about 6 in a billion chance of winning. Okay, not so good. Not so good. Okay, but 6 in a billion, it turns out, times, where was it? That one. 208 million is more than 1. Okay, so actually, if you don't take taxes into account, it's actually a good bet. Then there's taxes, and that's complicated. Any questions on that? Okay. Any questions on the lottery example? All right. Here comes the next one. Suppose that 20% of all students taking stats at LTCC are African American. And 40% of all stat students at LTC are non-STEM majors. Okay. If 22% of LTCC student non-STEM majors are African American, and you pick a randomly selected African American taking stats, find the probability the student is non-STEM. So one of the hardest parts about these kind of problems is not giving up. So here's my suggestion on doing these kind of problems that are like kind of a long paragraph and it can really like stress you out. My suggestion is read the problem, which we just did, and then go back and read it slowly. And every time you see a number, turn that into a probability. So suppose 20% of all students taking stats at LTCC are African Americans. Okay, so I can now turn that into a probability. I can say the probability of being African American, which I'm going to use A, is going to be equal to 0.2. Because 20% is 0.2. Any questions on how I was able to read that and turn it into an equation? 40% of all stats students at LTC are non-STEM. That is the probability of N, 0.4. Any questions on that? Then it says 20%, 22% of LTC stats students, non-STEM majors, are African American. So that means of those that are non-STEM, if we're told someone's not a STEM, there's a 22% chance that they're an African American. So that probability of African American given non-STEM is 0.22. Any questions on how I arrived at those three pieces? Okay, and again, the warning is it's much easier to watch me do it than to do it yourself. Because if you do it yourself and make one little mistake, you're going to get the wrong answer. All right, then find the probability. So then if you pick a randomly selected African American taking stats, find the probability the student is non-STEM. So now we know the person's African American. What's the problem of non-STEM? So that's saying probability of N given A. And that I'm going to write equals question mark because it's always a good idea to say, what do I need? What's my goal? If you don't know your goal, it's really hard to get it. Any questions so far? All right. So then you got to remember there were this equation, probability of A and B equals probability of A times the probability of B given A. And also the probability of A and B is the probability of B times the probability of A given B. Because A and B versus B and A, that means the same thing. Is that clear? Right? If you are African American and you are a non-STEM major, that's the same thing as being a non-STEM major and being African American. Do you agree? It's the same meaning completely. So I can solve for the probability of A given B by dividing left and right by the probability of A or the probability of B, whichever I want. Okay. So I want the probability of A given B, so I'm going to say the probability of A given B is the probability of A and B divided by the probability of B. Any questions on that? Probability of A and B is the probability of B times the probability of A given B. That's in that's our second formula here. So in this case, instead you can choose whatever, the letter doesn't matter. You can let it be N instead of B. So the probability of A and N is the probability of N times the probability of A given N. Any questions on that? Well, the probability of N is 0.4. The probability of A given N is 0.22. So I can just multiply those two. That's the probability of A and N. So now I can say the probability of N given A is the probability of A and N divided by the probability of A. Well, the probability of A and N we found was 0.4 times 0.22. That's the numerator. Probability of A was 0.2. So I put that in the denominator. I put that in my calculator, and I got 0.44. Any questions on that? Again, the big heads up warning is it's not that hard to watch me do it. But if you have to do it yourself, you have to know which step by step how to do this. Step one, write down all the numbers and their corresponding probabilities in symbols. Step two, think about what you want in symbols. Step three is often you're going to have to use a formula. Step four is plug in. And often step five is to make sure what you got is reasonable. If you got 7.3, it's wrong. You can't ever have a number bigger than 1. So that's a big note. So if we got a number at least that's smaller than 1, that's good. Any questions on this example? Okay. I think I'm going to go to the next thing because we do need to get to the project talk too. Make this a little bigger. All right, so now I'm going to talk about what a contingency table is. And I'm going to do it by example. Like that's the easiest way to really understand it. Notice I've done a lot of examples today. I'm not into just stating a bunch of theory because I think that will just confuse the heck out of everyone. So instead I do it by example. Okay, so now let's suppose a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. Okay. And, my guess is you're all going to transfer eventually. Okay. That's usually why you take a stats class. Okay. Although with online, sometimes you've already transferred and now you're taking this along with the rest of your courses that are in a bachelor's degree or master's degree or something. But we're going to pretend you're community college only students right now. Okay. And here is what's called the contingency table. So this is a table you'll often be given that looks like this. And what it will give you is rows and columns where the rows are the possibilities for one of the survey questions, and the columns are the possibilities for the other survey question. So notice the two survey questions where first one is, where do you plan on transferring to? And the choices are Cal State University, a University of California, UC place. And then if you're not in Tahoe, you may not even know what this is. But our closest university actually is not even in California. Okay, of the big universities. It's actually, I think of any. It's in Reno. So that's University of Nevada, Reno. So a lot of our Lake Tahoe Community College students go to University of Nevada, Reno. And then other, who knows? Maybe they're going to go to Stanford. Maybe they're going to go to, the Portland State University or something. Who knows? We'll just call those others. And then the second question is, what living situation are you going to be in when you transfer? And they might say, well, I'm going to be in an apartment. Maybe they'll say, I'm going to live with my parents. Or maybe they're going to have some other answer is, hey, there's a dormitory I can stay in, or I'm going to be homeless. I don't know. We'll call those others. Does that make sense? All right. So then there's all these numbers. So for example, this number 33. What that means is of all the students that were surveyed, 33 of them said that they're going to transfer to UC campus and live in an apartment. Any questions on how you read this question and how you read this number, what it represents? Okay, then the question is find the probability that a randomly selected student will go to a UC campus or live in an apartment. And just note, just to save us time, there are 246 students. If you add up all these numbers, you get 246. That was the sample size. Any questions on that? All right, so one thing to know, and let me do this. See this word or? I want to really highlight that. Because that's an important word. It's a really small word that's really easy to miss, but it's a really important one. And there's a big formula about or, and that is a probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Because the idea, if you add the stuff in A and the stuff in B, you're double counting the stuff that's in both. So that's why you have to subtract the stuff in both. That's what's going on. So for us, the probability of UC or A is the probability of UC plus the probability of A minus the probability of UC and A. So now we can figure those out. The probability of UC is going to be a fraction. And you say, well, how many UC students are there? Well, 33 plus 8 is, by the way, 41 plus 19 is 60. So there are 60 of these students are going to transfer to UC. And the total, as I mentioned, is 246. That saves us time. Then I'm going to add the probability of A. And that's going to be a fraction also. Probability of A is a total number in A, and A for apartment, by the way. And how many apartment residents are there? There's 43 plus 33, which is 76, plus 19, which is 95, plus 22, which is 117. You shouldn't completely trust me because I did it in my head, but I'm pretty good with arithmetic in my head. Let me double check. 22 plus 19 is 41, 74, 117. Good. I get it. I get it right. And then the denominator is still 246. And then minus probability of UC and A. That's actually much easier. Because UC and A, there were 33 of them. That's how you read that 33 number. Divided by 246. Any questions on that? Okay, to save time, I don't think I'm going to go through like how you put that in the calculator. But hopefully you're all okay with typing that in the calculator. I'm assuming that's something you can do. Because I want to get into a couple more things. One is a definition. Two events, A and B, are called mutually exclusive if the probability of A and B equals 0. So pretty much that says that they can't both happen. Any questions on that? So are transferring to a CSU and living with parents mutually exclusive? So what we can do is we can just find the probability of transferring to a CSU and living with parents. Well, you'll notice that there were 34 respondents that are going to be transferred to USC and live with parents. So we get 34 over 246, and that's not zero. Any questions on that? So if you calculate the probability and you don't get zero, then you say they're not mutually exclusive. So the answer is no. Any questions on deciding if two events are mutually exclusive? Okay. Let me give you a kind of a general example or a specific example about where things are mutually exclusive. Let's suppose that let's say A is the event. We surveyed a bunch of people. A is the event. The person was born in Mexico. And B was the event. The person was born in, let's say, Washington. Then those are mutually exclusive because the probability of being born in Mexico and being born in Washington is zero. You can't be born in both places. Hopefully you all know that. Any questions on that idea? Okay. So I had mentioned two events are independent. And now there's actually three different equations that all work. If and only if any of the three are true. Probability of A and B equals the probability of A times the probability of B. Probability of A given B equals the probability of A. Probability of B given A equals the probability of B. If one of those is true, they're all true. If one of those is false, they're all false. So what you typically do is the one that's easiest is the one you should check on. So notice this first one. There's actually three probabilities you have to calculate. I don't want to calculate three probabilities. So if we want to find out are living in an apartment and transferring to UNR independent, then we can just calculate the probability of apartment given UNR and see what that equals. Again, I'm going to insert an equation and I'm going to make it a fraction. And we want to find out the probability of an apartment given UNR. There was a formula for that. That was the probability of apartment and UNR, and that was 19. So the numerator will be 19. And probability, so the probability of our number in UNR, because we're given in UNR, so will be what? So you look at all the UNRs, 19 plus 7 plus 15, 19 plus 7 is 26, plus 15 is 31. And that's the probability of an apartment given UNR. Okay, because if you're given UNR, there's 31 of the possibilities, 19 of them are in an apartment. On the other hand, the probability of an apartment, that was 43 plus 33 plus 19 plus 22. We actually already calculated that. That was 117. And we're supposed to divide that by the total, 246. By the way, how do you tell if those fractions are the same or not? What's the easiest way? Any thoughts? What's the easiest way of seeing whether those fractions are the same? Because that's what we want to check to see if they're independent. Are the fractions the same? What's the easiest way? Let's see, y'all jumping in. Easiest way is to divide them, turn them into decimals. You're allowed, yeah, you're allowed to use a calculator. So 19 over 31 is about 0.6129. And 117 over 246 is about 0.4756. Are those the same? Should be obvious. Yeah, definitely not. 0.6129 is not the same as 0.74756. So if they're not equal, we can say therefore they are dependent. They're not independent. Any questions on that? All right, what I need to tell you is a secret word. The secret word for today, for this week, is given. Because when you had that little vertical line segment thing, you read that as given. Remember that? So given is the secret word. Don't forget to write that in your notes. So you don't have to, can't hurt to rewatch the whole webinar, but you don't need to. The secret word is given. Any questions on anything about probability? If not, what did I tell you we're going to do besides chapter 3? What else are we doing today? This is really important. So we're not even close to done. Yeah, the projects. All right, so I want to talk about the projects. So the projects, there's definitely steps to take. The first step, I'm hoping you've already taken. What was the first step for project 1? Yeah, find partners. So best, again, is a group of 3. Group of 3 is best. If you're a group of 2, it's not the end of the world, but 3 is better. Okay? So that's the best, is to find a group of 3. All right, I want to go to the syllabus now. And we can look at the projects. Okay, so I know I did this orientation, but I'm going to reread this. 2 projects will be created for the class. So we're now starting to think of project 1. Project 1, just note, project 1 is not due until October 20th, almost a month from now. Okay, why am I talking about it now? Yeah, get going, you're ready to start. And it turns out that project 1 is really all about chapters 1 and 2, which are really important chapters. Okay, so the other thing is this takes time. Okay, this does take time, so you want to set a timeline. First step was last week, and that is get project partners. Second step kind of is just listen to me right now, go and start hearing about the project. Okay, you're going to collect quantitative data. Do you remember what quantitative means? Who remembers that? We talked about that last week in the week 1 webinar. Yeah, it means it means that you're going to be asking a survey question, and you must ask a survey question. And every person who answers the question is going to say a number. Okay, So don't ask a survey question like, you know, do you like baseball? That's not a quantitative question because the answer would be yes or no. Does that make sense? So make sure that you have a quantitative survey question. Okay. One thing that you might want to do, and I recommend, is ask your partner the survey question. See what your partner says. If your partner doesn't answer with a number, then that doesn't work. Okay. And each person that you're going to ask is going to, possibly answer with a different number. Does that make sense? All right. You must use a computer and you must use a spreadsheet, by the way. I mentioned that last week too. Okay. See this link right here, Project One? I'm clicking on it. Okay, this is all on the internet. You can click it too, but I want to go through each of these little bullet points so that you get a really good idea of what this project is. Okay, so think of a quantitative investigation where you're going to ask people a survey question that someone might contract out to have done. So your next step is going to be to come up with the survey question. Come up with a person who might contract you out to do the survey. Okay, just let you know, this is in theory. You don't actually have to go and talk to the person to contract you out. But if there's nobody who would be interested in this project and the results, then this project doesn't work. Okay, and you should be interested in it too. Okay, that person could be Governor Newsom. You don't have to necessarily talk to Governor Newsom. It'd be cool if you could, but I've never been able to talk to the governor. But you can pretend that you were going to be taught that the governor contracted you out. Does that make sense? Okay. So there needs to be a person. That person could be the head of the counseling office of the college. It could be the, manager at some store that you are interested in. There's all kinds of different people that you can imagine contracting you out. Does that make sense on the person contracting you out? Okay. The next step, even though I didn't write this, but it is in the description of these projects, and that is right here. I'll be happy to look at a rough draft of your project if you can bring or email it to me at least by Thursday at 8 a.m. before it's due. Okay? Do not wait until the last minute because then I won't even look. Just note, if you email it to me on Thursday afternoon before it's due, I'll email you back saying, sorry, too late, but I'll read your project after you submit it. Okay, but not your draft. So don't wait until, Thursday after 8 a.m. to do that. Okay, but even better, I'll also take a look and help you out with your project idea. So if you remember, when you go to the discussion posts, there is the Project One discussion forum. You can click on the Project One discussion forum and you can type in your idea for the project. And here's what you should type in. One is your survey question. The next should be who your idea of the client could be. And then, and this is what we're going to be looking at next, a description of the sampling technique. So explain how are you going to use our sampling technique, and here's the choices you can do. You can use simple random sampling, stratified sampling, or cluster sampling. I have put a link for stratified sampling and cluster sampling, but I didn't link simple random sampling. How come? Any guess? Any guess why I didn't link simple random sampling? I don't see you guessing. Self-explanatory, definitely not. It's actually kind of invasive. No, that's not the issue either. Should I tell you? It's impossible in almost every situation. There are almost no situations where you can actually get a simple random sample. You would have to be able to list every single person in the entire population. So if you were asking, let's say, college students at community colleges in California, you would have to be able to get a list of every college student who attends any community college in California. You can't. That list doesn't exist that you actually have the right to get. It exists, but you go to jail if you went and hacked the computer system. So simple random sampling, think again if you think you can do that one. Talk to me a lot because it's almost always going to be no, because it's pretty much impossible. On the other hand, stratified sampling, that one is very doable. So stratified sampling, remember there were step-by-step processes, and I have a link to it and it gives you all the steps, but I'll just say it quickly. First step, decide what your strat are. Second step is to research the percentage of each of the strata in the population. Third step is to multiply your sample size by the percent to create your quotas. And fourth step is to conduct your survey. Okay. The other choice is cluster sampling. Cluster sampling is breaking up the population into clusters and then picking a few representative clusters that don't have an enormous number of people. And then the next step is to ask everybody in each of the selected clusters. Any questions on those? All right, so then once you've decided, post it on the project discussion board. I'll let you know if it can work or not. And sometimes they'll say, great, looks wonderful. But usually I'm going to say, it looks really good, but there's this one little thing that you're going to have to change a little bit, or it doesn't really fit in with the requirements, or you're not going to be able to do it or something like that. So then make sure that you look at it and you can get help. You can ask me, you can ask the tutors. You can ask Kyle, who's your embedded tutor. Lots of different ways. Okay, so in your paper, you're going to have to talk about all the stuff that you're doing. You're also going to have to discuss any bias that might have occurred due to your sampling technique. If you think there is no bias, think again. Okay, you're not deducted points for having bias. You're deducted points for not identifying the bias. Do you see the difference? You're almost certainly going to have bias. If you say there's no bias, I'm going to look, and if I find bias, I'm going to zap you with take off a lot of points. Okay, so identify bias. Bias represents a misrepresentation of the population so that the sample data will not represent the population data. Okay, you need to explain all that. How, why is yours biased and why does it not represent it? And particularly, it doesn't represent it based on the survey question that you're asking. Okay, so why is it that your mean, your sample mean, is more likely to be bigger or maybe smaller than the population mean based on this bias? Okay, any questions on that? Okay, so again, a convincing argument. Okay, that's all written in the paper. All right, the sample size must be greater than 30. By the way, what's the smallest sample size you're allowed to have? Yeah, 31. If you have a sample size of 30, that's too small. 31 is fine. 40 is fine. 500 is way too much work. The only reason why you'd ever do 500 for the project is if you were also doing it for your job and you're getting paid by some manager. Okay, and that's happened actually. I've actually had students that did it for their work. Okay, and that can happen. I have no idea what all of you work at, but usually you do it for this class, and then a number a little bigger than 30. Okay, sometimes 32 if you want to like each do 16, so you can have an even, or sorry, 33, so you could each do 11, because then you're sharing the pain equally. But 31 is fine. Any questions on that? All right. Is there always bias? Absolutely. There's pretty much always bias in any survey with people. Okay, the bias can also happen in how you ask the question. Could be other things when you ask the question, things like that. All right. Here's a very, very dangerous word to use, and that's random. If you think you can randomly select people, think again. It's not going to happen. Got it? Okay, random is almost always impossible. So you better explain what you mean, and you better justify that word random if you're going to use it. Okay. As I mentioned, simple random sampling is almost impossible. So good luck. There's been like maybe one or two in my like 28 years of doing this where it actually worked, but it almost never works. Any questions so far? Okay. So you must create the charts, all the relevant charts, and absolutely required are the 3 charts: a histogram, a stem and leaf, and a box and whiskers plot. Okay. You can include others like a pie chart or line chart. Those aren't necessarily required, but only if they're relevant. But these 3, histogram, stem and leaf, and box and whiskers, if they are not relevant, this project will not work. So here's a note that a lot of people make mistakes on. When are box and whiskers charts not relevant? Anyone, any idea? Or almost certainly not relevant, at least. Okay, what if the survey question was something like, how many sisters are in your family? Do you have? Why would box and whiskers not be relevant? It's not about not enough data. You don't need a huge data set. In fact, if you have too big a data set, then stem and leaf is not good. But no one's going to have, 1,000 things in your data set. But what are box and whiskers? What's wrong with the survey question? How many sisters do you have? Any thoughts? Let's see jumping. Let me tell you. Okay. I'll let you post it. How many sisters do you have? Put it in the chat box. Don't worry, it's all private. How many sisters do you have? Okay. Put your answer in the chat box. And you'll see the problem, maybe, if you understand box and whiskers plots well. All right, here's the problem. Okay, I'll even put mine in the chat box. And I'm going to do full sisters. So 2. Okay, I have 2. All right, here's the problem. Box and whiskers plot, if you remember, there is, oh, sorry, actually box and whiskers be all right. I'm my mistake. Stem and leaf is the issue. Why is the stem and leaf plot not relevant for that question? Highlighted the wrong one. Stem and leaf plot. What's wrong with the stem and leaf? Okay, remember the stem is 1 digit and the leaf is the next digit. But if you ask how many sisters do you have, just about everyone is going to give you single digit numbers. Do you see that? And if just about everyone's giving single digit numbers, then the stem and leaf doesn't help. Do you see that? Because you're only gonna have one stem, 0. And it's going to be wasted. It's no different than just ordering the numbers. So make sure that your survey question has at least 2-digit numbers. Any questions on that idea? It's a mistake a lot of people make. All right. So all charts and statistics must be done using the spreadsheet. I mentioned that last week. Okay. Note that this is not a comparison study. Okay. You're going to have a single column of data, period. Do not compare this versus that. You're not supposed to do that. Okay. I will let you know. Any guess on when that's going to happen? Just as a guess. When you do a comparison study, it's going to happen, but not for project 1. Any guess? Project 2. Project 2, you're doing comparison study. So project 1, you're sticking with just one data set with that just one column of numbers. So it's a single column numbers, okay? And you're going to get a sample mean, just a single sample mean. You're going to have a sample standard deviation. You're going to have a histogram, etc. Any questions on that? Okay. And you should use the spreadsheet that I showed you. If you click Project Spreadsheet Resources, and click this guy, and click Starting Out here, then you're going to get a file. You're going to hit Make a Copy. Give it a name and hit Make a Copy. I'm not going because I already have my copy, but you have to make a copy. And then this is Google. You can share it with your partner. You should share it with your partner so you can all see it together. And I coded all this stuff out. So it all works for this project. And then you're going to put your numbers in, and it'll give you all the minimum, the mean. Sample variance, don't look at. Sample standard deviation, that's a biggie. The median, the maximum, Q3, and stem and leaf, you'll probably have a 1 there. Q1, that's important. And the box, you can choose to ignore outliers or not ignore outliers. Don't worry about these guys. That shouldn't be in your project. Any of this confidence interval or H1 and stuff, or T or P, just ignore them. That comes after this project. Don't worry about these guys. That was for a different college. Z-score is important. Don't forget, don't leave this as 106. You should use the Z-score to decide on do you have outliers or not, and also how normal is the kind of important data value if there's an important data value. IQR is important. Most of this other stuff is not important. Okay. Okay, you should list the summary statistics. Okay, the important ones, and make sure you interpret each. Okay, these should be like paragraphs long, not a few words. Okay, mean, median, standard deviation, those are important. Standard deviation is especially important. Okay, several other stats that we mentioned in this class. Standard deviation is a biggie. You must have at least a full paragraph that is devoted to the standard deviation. Okay, otherwise no one will get an A if you don't have a full paragraph. All right, just a note, Z-score is part of the standard deviation idea. So that's part of that. Outliers are part of it. And the standard deviation itself is part of it. Okay, also either the empirical rule or Chebyshev theorem, which is the one that's relevant to your project. That you can only tell after you've looked at the histogram. and then talk about it. And what does it say about the population? Okay. All right. Very important is to make sure you interpret the statistics in the context of the survey. Don't just define what standard deviation is defined as. Talk about how your client is going to use each of those values to make decisions. What decision will the client make after looking at the standard deviation? What decision will the client make after looking at the median? Okay, for each of them, what decision will the client make and why? Okay, so include recommendations from the client based on all those different things. Looking at the chart, what decisions will the client make after looking at the histogram, after looking at the stem and leaf diagram, after looking at the box plot? Okay. Any questions on all this? Okay. And then at the end, you should talk about how you can do further studies to delve deeper into the topic and also maybe reduce bias because you identified the bias early. So at the end, you talk about, well, what might you do to deal with that bias so you can actually do a better survey? Okay, that's all in theory. You don't have to do it, but what could you do? Any questions on that? All right. I have some examples of feedback that I've given. And if you click on this feedback on project one, it'll give you feedback that I've done for other students. Any questions on that? I'll let you read through the rubric. Okay, so just a note for the timeline. I recommend not waiting till and let's go back. I recommend not waiting until the night of October 20th to submit the project. Might be a good idea to actually have it submitted on the 19th or the 18th. So that if something goes wrong, you get an extra day or two. Do you see how that works? That's a good kind of life skill. When you have something important, don't wait till the very last minute. And this one's an important piece of the class. It's 10% of your grade, by the way. Okay. So don't wait till the last minute for that. Okay. Instead of by Thursday morning, maybe like Tuesday before it's due to submit your draft to me. It takes me some time to read that draft. Okay. It's many pages and many people submit. And I read it on a first submitted, first read basis. So if you submit it at 7:59 a.m. on Thursday, I might not get back to you until Saturday because if everyone's submitting late, it's going to take me time. Does that make sense? So don't wait till the last minute to submit either. Okay. And I recommend, like I said, maybe within the next week, have your project idea, discuss with your project partners, and post it maybe 7 days from now or so. Post it on the project discussion board. It'll take me a day or so, and I'll be able to answer and let you know if it can work. If not, if I say, no, this doesn't work at all, then you got to start over again and you got to talk to your group and come up with something else. Okay, that happens sometimes. Usually it happens because the survey question is qualitative instead of quantitative. Okay, or can't be answered with enough variety of numbers. It's only one digit, for example. So those are big problems that could happen. But then once I've told you, then it might take another week for you to actually collect your data to conduct your study. One real important rule, this is a biggie. You are not ever allowed to ask children the survey question. Okay, anyone know why? There's a reason. And here's a hint. I'm now I'm going to post this on YouTube. I am now on recorded YouTube telling you cannot ask children. You know why you can't? It's minors, and the problem with minors is it's against the law to ask children without all kinds of legal things. And with this project, you don't have time to get all the legal stuff done. So don't even think about asking children. The only children you're allowed to ask if it is a college student that's one of your fellow students, then you're actually allowed to ask that person if, say, they're 17 years old, not quite 18 yet, then it's allowed. And that, you may not know it, but their parents actually have to sign something that says that people are allowed to ask them things. That's actually part of the law. But if it's not one of your fellow college students, don't even think about asking children. Okay. And funny thing is, I actually know one of my students asked the child once. It was like 16 years ago. My daughter came back from high school. I think she was a sophomore in high school. And so one of my students asked her the survey question. It's like, no, not allowed to do that. I didn't sue the student, but I could have. So don't ask children. Got it? That is not allowed. Also, if you're going to be going to a company to ask people, adults, make sure you ask the manager that get the okay from the manager to ask first. I don't want anyone getting fired from their job, for example, because they did a survey because I told them they had to do a survey. Make sure you get permission from the manager first. If you're going to go to a classroom and ask students in the classroom, get the professor's permissions first. And professors almost always say yes, almost never say no. But you should always ask. Sound good? Okay, so that's pretty much everything I need to say about the project. It's just about the very last moment. I like to be done like within 15 minutes of 7:30, and it's 7:43 right now. So I am going to say we're finished, and always happy to ask questions after I stop the recording and undo the share. But thanks a lot. So I'm going to stop the recording.